Hello, thank you very much for joining. This is Leandro Mora and this is the second lecture of the NoSQL training. Today we're going to talk about the relational data model. So to start, I would like you to think in the following question. How do we store data? If we talk about hardware, we may store the data on hard disk or on solid state drivers. On the other hand, if we talk about the logical way of storing data, we can think about storing data using a file system, or we can store the data on a table on an Excel format, on an Excel file. If we continue talking about the logical way of storing data, there is an interesting concept that I would like you to think, and it's a data model. A data model is an abstract model that organizes elements of data and also standardize how they relate to one another and to properties of the real-world entities. The data model is composed by three elements. The first one is the structure, and it determines how the data is organized on the data model. Here we can see three examples of different structures. For information, the last two items of that list are going to be covered by this course. The second component of the data models are the operations. You may find them familiar every time that you insert a row on a relational database. Every time that you do a select operation, you are performing an operation. And the third element, which is really important, are the constraints. The data model, it's defined with several constraints, and the operations performed on the data model must follow different constraints. Here we can see some examples of those. So now that we have talked about a data model, we would like to go deeper and talk a bit more about the relational data model. In the past lecture, we have talked about the database management systems. The database management systems who uses the relational data models are called the relational database management systems. Kurt Monash and Alice Blogger defines that a relational database management systems were invented to let you use one set of data in multiple ways, including ways that are foreseen at the time the database is built and the first applications are written. If we are going to talk about the relational data model, we can't omit Edward Codd. Edward Codd was an English computer scientist who, while he was working for IBM, invented the relational model for database management, the theoretical basis for relational databases, and also the relational database management system. In 1975, he wrote the paper A Relational Model of Data for Lang Shared Data Banks, and he defines the relational data model with three rules. The first one is that everything is stable. The second one is that every row in a table has the same columns. And the third one is that relationships are implicit. There are no pointers. Besides, he defines relationships. A relationship is a set of tuples where each element is a member of a domain. We commonly refer a domain as a data type. Finally, our friend Codd defines the relational algebra, which is used for modeling the data stored in relational databases. It describes operations and relationships between that operation and functions. Here, for instance, you can see some operation that, if you have ever worked with relational database, you may find familiar. Selection, projector, join, are normal operations that we use on a daily basis if we have ever worked with relational databases. Now that we have defined relational databases, it's a good moment to talk about how are the changes in a relational database performed. And the changes on a relational database are performed by transactions. Transaction can be seen as a unit of work performed within a database management system against a database. Each transaction is independent of another transaction, and a transaction may consist of one or more data manipulation statements and queries. There are 4 principles that the transaction on a relational database must follow. And the acronym of that transaction is ACID. And these are the 4 principles that the relational database the transaction of a relational database must follow: atomicity, consistency, isolation, and durability. Let's start for the first one. Atomicity. Atomicity declares that a transaction must provide an all or nothing principle, which means that if one part of the transaction fails, then the entire transaction must fail, and the database should be left unchanged. The transaction is indivisible. Either all the statements in the transaction are applied to the database or none are. The second principle is the consistency. Any data written to the database must be valid according to all defining rules, including constraints. And there is something important. This property ensures that any transaction will bring the database from one valid state to another valid state. The third principle is the isolation. While multiple transactions can be executed by one or more users at the same time, one transaction should not see the effects of other in progress. And the last one is durability. Once a transaction has been committed, it will remain so. Its changes are expected to persist even if there is a failure of operating system or hardware. Now, let's check an example. Imagine that an e-commerce platform hires you for creating the module that is in charge of managing the money trace between users. Let's see if all the properties of a transaction must be accomplished. Why the transaction of this e-commerce platform have to be atomic? Remember, atomicity implies that a transaction must provide an all or nothing principle. We would not want to see an amount of money removed from one account, from the origin account, before we are sure that it has been transferred into the target account. Extract money from one side and put into another account must follow the all or nothing principle. If there is an error in the operation, the money should be kept in the origin account and the target account should not suffer any modification. Then, the second principle. Why these transactions have to be consistent? Remember, the consistency principle determines that any data written to the database must be valid according to all defining rules, including constraints. Imagine that if you extract money from an account, you may be interested in checking that it has the necessary funds for doing that operation. If that's not the case, you cancel the operation. You don't even perform it. The third principle, why these transactions have to be isolated. Recall, isolation principle declares that as multiple transactions can be executed by one or more users at the same time, one transaction should not see the effect of other in progress. And let's read the slide. To demonstrate isolation, we assume that 2 transactions execute at the same time, each attempting to extract money on the same account. One of the 2 must wait until the other completed in order to be sure that after the first one is completed, the second has enough money available. It makes sense. And the fourth one is why this transaction, the transaction that we are going to perform on this relational database, has to be durable. Remember, the durable principle says that once a transaction has been committed, it will remain so. Its changes are expected to persist, even if there is a failure of operating system or hardware. Imagine that there is an electrical shutdown in the data center, and a money operation has been committed. The user who sold a product will not tolerate that the money was not deposited on its bank account, or that it was there and after some minutes it was gone. So that's all for now. This has been the second lecture of the NoSQL training, and hope you enjoy it.